So linear functions are repeatedly adding or subtracting the same amount. Since it's repeatedly adding or subtracting, it's what we refer to as being constant. It's always going up or going down by the same amount. That's like one of the biggest things you have to be able to remember to understand about your linears. Always the same amount. Our exponentials, though, are based on repeatedly multiplying or dividing by the same amount. So the actual amount of increase is always going to be different. So if you recall, let's say we had 1, 2, 4, 8. We're always multiplying times 2, but this one increased by 1, increased by 2, increased by 4. So the amount it actually increases by is different. That's the thing with your exponential. So we looked at table of values to identify whether it was linear or exponential. Sometimes, though, and that's what we're going to get into today, sometimes you are purely just given a list or a pattern of the values instead of a table. So it's really the same thing. They're just giving it to you in a different way. Instead of giving you the full table, they're just giving you the list. So this list is what we call a sequence. You're being given a sequence of numbers. And that's just numbers that are related to each other in some way, either by adding or by multiplying. So a sequence is an ordered list of numbers that form a pattern. There are a whole bunch of different kinds of sequences out there. We're only going to talk about 2 types today. So for example, this list of numbers right here is a sequence. Those are what we call the even counting numbers, 2, 4, 6, 8, 10, ... So that is a sequence of numbers. There's a pattern to it. How do I get from one number to the next? You're adding 2 every time. So that's our pattern. It's always plus 2, plus 2, plus 2. So this represents a linear function, just like we were talking about last time, since you're always adding 2. So this would be a linear sequence, because you're always adding 2 to get you to the next number. Now we could take that list and we could make it into a table also, and I'll show you that in a minute. So each number in our list is called a term. So the number 2 is a term, number 4 is a term, 6 is a term, 8 is a term. Those are your terms. And we have 2 different ways that we can write our sequences. It's either this notation right here with that little a and then a little n. We call this a sub n. That means it's a little subscript. So you know how we have an exponent? It's like a little number up at the top. Our subscript is like a little number down at the bottom. It's like the opposite of your exponent. Or we can use our function notation. This just be a of n. Just like all of our other function notations, f of x, g of x, that would be read as a of n. So it doesn't matter which of those 2 ways they do it. If they write it as a sub n, or if they write it as a of n, it's both the same thing. So if we take a look here, I have my pattern started 2, 4, that would be 6, 8, 10, 12. This was our sequence that they gave us. They originally wrote this. Guys, you got to stop it with the goofiness today. So I took my sequence that they gave me here and I wrote this as my term. Now to create the table that I was saying you could make that you guys are used to making, your x value would be your term number. Your y value would be like the term itself. So the number 2 is term 1. So it's kind of like I have the point 1, 2. The number 4 is term 2. Number 6 is term 3. 8 would be term what? 4. 10 is term 5. 12 is term 6. And then if it's talking about a term that they don't even know what it is yet, they just call it n. Because that means I don't know what term I'm looking at. I'm just going to call it n for now. So you can make your sequences and make them into a little table if you want to see the table. It might make your life a little easier. So then for our notations over here, for our subscript notation, if I'm talking about my first term, I would write it as a sub 1. But in function notation, that would be a of 1. It means the same thing. That means I'm looking at my first term since I have the number 1 in there as opposed to an n. A sub 2 in function notation would be written as a of 2. Those are the same thing there. That means you're looking at your second term. A sub 3 is my third term. A sub 4 is my fourth term. So my fifth term would be a sub 5. My sixth term would be a sub 6 or a of 6.
Will you always use both notations?
No. They're just interchangeable.
So they both
They've been the exact same thing, yeah. So let's see here. I'm going to come up with a list for us. Here's our sequence. Let's say I ask you for what is our third term? What is our a sub 3? Caitlin? 9. 9 would be our third term. First, second, there's our third term. What if I asked for a of 6? 18. That would be our sixth term because it's the sixth number in the list. What if I asked you, so this is asking, what term is 12? A sub n equals 12. They want to know what n is. N would be 4. Good. Because 12 is your first, second, third, fourth term. So n is 4. N just means what term am I looking at. Okay? So questions on that stuff so far? We doing okay with our sequences? Okay. All right, so as I said, we're going to deal with two types of sequences. First one is arithmetic sequence. Your arithmetic sequence is a sequence in which the form or the pattern is formed by repeatedly adding or subtracting a common value. So your arithmetic sequences, they look a lot like your linear functions. Arithmetic sequences, your linear functions, those are pretty much the same thing. So, for example, the set of even counting numbers we were dealing with are 2, 4, 6, 8, and 10 is an arithmetic sequence because you're always adding 2 to get you from one term to the next, as we talked about. So the number being added to each term is called the common difference. So in our example there, our common difference is a 2. Because you're adding 2 each time to get you to the next number. Your common difference is also very similar to your what? It's your slope. Common difference is your slope. They're just using a different word for it, but it's the same thing. So graphs of arithmetic sequences are lines. They follow your y equals mx plus b pattern. When you write equations for them, you'll see it and you're like, oh my gosh, that looks like a linear equation, because it does. determining a pattern. We're going to take a look at these, identify the missing numbers in our pattern, and then figure out if it is arithmetic or not, yes or no, and then what is your common difference. So here we got 5, 8, blank, 14, blank. So what would be our first blank? 11, and our last blank? 17. Is this sequence arithmetic?
Yeah.
Yes. Our common difference was what? 3. So we got 5, 10, 20, 40, 80, and 160. Is this arithmetic? No, because what were you doing each time? Yeah, times 2. Since it was multiplied, not arithmetic. So there is no common difference because it's not even an arithmetic sequence. Okay, then our next one we got 15, 11, blank, 3, blank. 7, -1. Oh, I didn't mean to circle, no, sorry. I was thinking of something else in my head. So our common difference would be -4, because you were subtracting 4 each time, so your common difference is negative. So writing what we call an explicit formula for your arithmetic sequences. So that just means writing a formula for your sequence. That word explicit, don't get hung up on it. That just means you're writing a formula for it. So when you are writing your formula, you need to use this equation right here, which is given to you on your Regents exam. So you don't have to memorize that one, you just have to know how to use it. So I made this little list here for us. A sub n, that is your nth term of your sequence. We generally don't know that one. That's usually the one we're trying to find. Like they'll ask you to find the 20th term of your sequence or find the 100th term of your sequence. So that would be your nth term. That's the one we're looking for. A sub 1, that just means what is your first term. Remember that 1 in there tells us we're looking at the first term. Your n is the term number. So if I'm looking at my 20th term, my n is 20. If I'm looking at my 5th term, my n is a 5. It's just whichever one we're looking at. And then your d, that is your common difference. How are we getting from one term to the next in our sequence here? So when you are trying to write your sequence, you want to follow these steps here. First thing you want to figure out is what is your common difference. So if we look at our example here, what are we adding each time? 6. So our common difference is 6. Next, they want to know what is our first term. So our first term is 3. So our a sub 1 equals a 3. So then you're going to write the sequence in notation using either a sub n, or you can use the function notation a of n. It does not matter which one you use. Let's use our function notation this time. So we'll use a of n equals. I'm following my formula up here. So it tells me my first term needs to go first. So 3 and then plus. We don't know our n yet. So that's going to stay as n minus 1 inside those parentheses. And then our common difference, the only thing you want to do with your common difference is make sure you put it in parentheses because it needs to be multiplied. So many times, here I'm just going to show you this on the side, don't write this one. If your common difference is a negative number, let's say it was -6, if you don't put it in parentheses, you just think you're subtracting a 6 at the end. But you're not. You have to make sure you're multiplying it. So that common difference always needs to get put in parentheses. Did you have a question, Josh? So here we're going to write the explicit formula for the sequence that they've given us there. So 5, 8, 11, 14, 17. So let's go through our list. We got to first find our common difference. What would our common difference be here? 3. We're adding 3 each time to get us from 5 to 8, 8 to 11, 11 to 14. Next, we need our first term. A sub 1 is 5. So then our third step is to actually write the equation. So I'm going to write it in the other form this time. A sub n equals, again, I'm just following my formula up here. So it tells me my first term, so 5 plus, I don't know my n yet, so n minus 1, and then times 3. So now this right here, that is a perfectly good way to write it. So if this were a short answer question, you could leave it like that. The only unfortunate thing is a lot of times if it's multiple choice, they don't leave it in that way. What they do is they simplify it up a little bit. So like this 3, they would distribute through the parentheses there. So a sub n would equal 5 plus 3 times n gives us, and then 3 times negative 1, give us minus 3. And then we just need to combine our 5 and our minus 3. So a sub n would equal 3n plus 2. This is the one you will generally see as your multiple choice question. So it's the same thing, just written in 2 different ways. Same. And as I said before, this right here, that looks a lot like your mx plus b. It's just instead of an x, they have an n. So now part B, they want us to determine the 10th term of your sequence. Now we have a value for our n. We're going to plug a 10 in for our n. So a sub 10, I'm looking for my 10th term. I'm going to use this one here that we just did. So I'm going to do 3 times 10 plus 2. So we get 32. So our 10th term is a 32. Good.
I'll just have the math use if you want to.
All right, let's go to our next one. So our other type of sequence is our geometric sequence. So we have our arithmetic, which is your adding. I always remember them because they both start with A. Geometric is formed by multiplying a fixed number to each of the previous terms. So this one's like our exponential, because our exponential was multiplying, our geometric is multiplying. So those two are good friends too. So our example here, 1, 2, 4, 8, 16 is a geometric sequence because you're multiplying times 2 to get you to from one term to the next. The number being multiplied is called the common ratio. So in my example up there, my common ratio is 2, because that's what I'm multiplying times each time. So graphs of our geometric sequences are exponentials. They look a lot like your a times b to the x that we've been working with this unit. So much like our arithmetic sequences, we do have to write formulas for our geometric. Again, this formula is given to you. You just need to know how to use it. So our a sub n, that doesn't change. That's still the nth term of the sequence, whatever number you're looking for, whether it be the 15th term or the 21st term. Your a sub 1 here, that's still your first term of the sequence. We always need to know that one. Your n, which is up in that exponent spot up there, that is still the term number, so that hasn't changed. And then your r, that's going to be our common ratio. So down below, our steps for writing it are very similar to our steps for writing our arithmetic sequence. You first have to find your common ratio, just like we had to find our common difference before. Your common ratio usually is going to be pretty easy to see. What are we multiplying by each time here? -2. Your sign value keeps changing. It goes positive, negative, so that means your r value is a negative. And then 3 times 2 gives you 6, 6 times 2 gives you 12, 12 times 2 gives you 24. If you could not figure it out, the easy way to figure this out is you take your second term, put it over your first term, and that's your common ratio. All right, next step, we need our first term. What is our first term? 3. So then our formula, I'm going to use a sub n this time. Again, I'm following this right up here. It says for me to use my first term times my common ratio of -2 to the n minus 1 power. So it's 3 times -2 to the n minus 1. That's it. So they want us to use this formula to determine our 8th term of the sequence. So I'm going to look for my a sub 8. I'm going to plug in an 8 for my n. So that's 3 times -2 to the 8 minus 1. Yep. So that's 3 times -2 to the 7th. Then you can just use your calculator. Does everybody agree? So, how are we doing so far?
Great.
Okay. This last part, I don't think I should have to teach you. No, I have to. It's always on the regions. All right, our last one is our recursive formula. Recursive formulas work for both of your sequences, both your arithmetic and your geometric sequences. The way I remember your recursive formulas, you guys know generally how to write cursive handwriting? A little bit. I'm not asking you to actually do it. I'm just saying, like, if I'm writing the word bed, everything's connected together, right? Cursive handwriting, it all flows. Bead. Oops, I did my D wrong. But anyways, the reason I do that is recursive formula is like cursive writing. Every letter's connected to the one before it. Your recursive formula, every term is connected to the one before it. So I can't figure out my second term until I know my first term. I can't figure out my 5th term until I know my 4th term. But to get that one, I need to know my 3rd term. And to get that one, I need to know my 2nd term and then the 1st term. So they're all connected. That's the thing with the recursive formula. So it involves the repeated application of a rule. So you're always constantly like multiplying times something, or you're always adding something to get you to your next number. So our notation for our recursive formula, that's what the tricky part actually is. So we have down here, if a sequence is defined by this, and there are 2 parts to it, they want to know what is f of 2. Which? F of 2 means which term am I looking for? I'm looking for my 2nd term. F of 2 means I'm looking for my 2nd term. So let's go back and read through what we have. They tell us f of 0 equals a 2. So I know my 0 term, which normally they don't give you that one. I like to make a little table for my recursives. I think it makes it easier. So my 0 term is a 2. I want to know my second term, but I have to get my first term before I can get my second term. Remember, these are terms. That's your number. So my 0 term is a 2. So then if we look at this next part, it says f of n plus 1 equals negative 2 times f of n plus 3. And I get it. That looks like, oh my God, what the heck are they talking about? So this notation right here, f of n plus 1, that means your next term. Whenever they have it written like that, f of n plus 1, they're telling you your next term. So if I have term 0, what would be my next term?
3. 1 is 3.
My next term would be term 1. I have term 0. My next term is term 1. So that's the next one I need to find. So to do that, what they're telling us to do is negative 2 times f of n, which would be, didn't mean to write that, which would be f of 0 plus 3. So I know what my f of 0 is. They told me that was a 2, so I just got to plug 2 in. So what's negative 2 times 2? Negative 2 times 2 plus 3. So our first term would be negative 1. So now to actually get my second term, which is what they really wanted to begin with. So now I'm at my first term. My next term, which would be my second one, so f of 2, my second term, is negative 2. That right there means your previous term. That's what we just figured out. So my previous term to my second term would be my first term, which was negative 1, and then plus 3. So negative 2 times negative 1 plus 3 is 5. So again, that's the tricky part of the recursive. It's always telling you to go to the next term or the previous term, and you have to be able to read that notation to go along with it. N plus 1 is next term.
Plus 3 equals 5.
Yeah, equals 5.